this video, we're going to have a look on geometric sequences and series. A geometric sequence is formed by multiplying or dividing the previous term by the same number. So in the first example, as you can see, you multiply 2 by 2 to equal 4, by 2, 8, and by 2 equals 16. So we multiply each time by the same number. So we can say that the common ratio R equals 2. You can always get the common ratio by dividing any term by the previous term. So if I said 16 divided 8 equals 2, 8 divided 4 equals 2, 4 divided 2 equals 2. In the second example, you can get the common ratio by dividing any term by the previous term. So 27 divided -9 equals -3, or -9 divided 3 equals -3. In the third example, 16, this time you're going to divide. Divided by 4 equals 4, divided 4 equals 1, divided 4 equals 1 over 4, and till 1 over 16. So you can get the common ratio R by dividing any term by the previous term, which is 1 over 4. In the next pattern, you want to check first if it is a geometric sequence or not. So if you divide 10 by 2 equals 5. If you divide 15 by 10, it will not be 5. Okay, it's going to be 3 over 2. So this is not a geometric sequence. A geometric sequence is defined by the rule you can see on the left, and this rule is available in the data booklet. Un is the value of term of the nth term. N only is the number of term. U1 is the first term, and R is a common ratio. So in any geometric sequence, you may write it as U1, U2, U3, U4, etc. and relate every term to the first term, U1. So U2 is U1 multiply R. U3 is U2 multiply R. U4 U3 multiply R. To relate every term to the first term, so U2 is U1 R, and U3 is U1 R power 2, U4 is U1 R power 3. This is going to help you to answer most of the questions of the geometric sequence. Examples on a geometric sequence. In example 1, you have a geometric sequence with first term 3 and the common ratio -2, and he asked for the 10th term. You may use a general rule. You want to find U10 equals the first term 3, U1, multiply the common ratio -2 power the number of term -1, which is 9. You may use your GDC to evaluate the answer. So you have 3 multiply -2 all power 9. The answer is -1536. In example 2, you have the second term of a geometric sequence is 6 and the fourth term 9, 6. You want to find the possible values of the first term and the common ratio. Pay attention that he said possible values, so you're gonna have more than one value. So U2 equal 6 and U4 equal 9, 6. U2 is U1 multiply R equal 6, and by the same way U4 equal U1 R power 3 equal 9, 6. You may divide U4 by U1, so it's gonna be U1 R power 3 over U1 R equal 9, 6 over 6. U1 is cancelled with U1, U3 over, R power 3 over R is R power 2 equals 9, 6 divided is 16. Taking the square root of both sides, so R equal positive or -4. So when R equal 4, U1 you may substitute in any equation from the two you have. This one is simpler. So U1 6 over 4 simplified to 3 over 2. And when R equal -4, U1 equals 6 over -4, which is -3 over 2. There is other way, gonna save you couple of steps. In any geometric sequence U1, U2, U3, U4, you get any term by multiplying the previous term by the common ratio. So you get U4 by multiplying U2 by R by R. So U4 equals U2 by R, which is R squared. Now substitute with the value of U4, 9, 6 equal 6, U2 equals 6, R squared. So R squared equals 16 and R equal positive or -4. Now we're going to substitute and define U1 by the same way. So U1 equal 3 over 2 when R equal 4 and U1 equal -3 over 2 when R equals -4. In this example, you want to find the number of terms of the geometric sequence. You have the last term, 512. You may use the general rule. So UN, the value of UN 512, and you have the U1 equal 1, and the common ratio, any term divided the previous term, so equal R equals 2, U1 equals 1. Substitute in the rule, so 512 equals 1 multiply R 2 power n minus 1. 512 is 2 power 9 equals 2 power n minus 1. Now you have base equal base, so power equal power. So n minus 1 equals 9. N equals 10. Now with the sum of the first nth term of a geometric sequence. In the data booklet, you're gonna have two rules. I prefer this one because it's look like to the rule of sum of infinite geometric sequence, which you're gonna study later. So in example 4, a geometric sequence has first term 16 and a common ratio negative 0.5. Find the sum of the first 8 terms to 3 significant figures. Direct substitution, so you have SA equal U1 16 by the common ratio 1 minus the common ratio, so 1 minus negative 0.5 all power 8 over 1 minus negative 0.5. You may use your GDC to evaluate the answer, which is going to be 10.625. Pay attention to how you write. In the denominator you have negative negative, so you may write it as positive here. In the numerator, you have to evaluate the power first, so it's negative 0.5 all power 8. You can't write it as 1 plus 0.5 power 8 because it's gonna be wrong. That's for today. Thank you and good luck.